Morning, everyone. This is Mr. Lee recording this video for Algebra 1 students. Today, we're going to talk about the concept about slope. Many students have thought that we don't use the algebra concepts in the real life. Well, actually, we use it. Most students just don't see it as in real life. So I'm going to bring you this some examples so you can really see slopes in the real life. So let's start. Get ready. Let's go. So first of all, we need to understand the concept definition of slope. And slope is defined as rise over run. Up to now, you probably say, "Oh yeah, again, mathematical term, rise, run. This is boring." But hang in there. We are going to go to the real life. We are going to connect this rise over run with the life activities you sometimes or really easily see in the real life. So it's defined rise over run, or some even more mathematical term you see delta y over delta x. In math, when you see delta, this little triangle, that usually means the change of values. For example, um, you have a number 2 increases to 7. So the value of change of these two numbers is increasing by 5. So 7 minus 2 equals 5. That's how you understand this little triangle here. Y stands for the y coordinates. So delta y at that can be translated into delta y means change of y coordinates. Delta x, of course, that means change of x coordinates. All right. Up to now, you probably still say, well, still very mathematical, right? Now, we are going to show you how this concept that you can find um, in the real life. Let's move on. For example, if you can really make the growth of a tree like a very, really fast, you will see this, right? Growing, growing, growing. I know takes about 100 years to grow so tall, right? But that you can imagine. If you really take a picture and lay it out like this, you will see this one, this line here. And now the change of y means the change of the height of the tree. Now increase this much, right? And the next year increase this much, increase this much. Let's say the growing situation like rainfalls, sunrise, sunsets, they are the same every year, then we should be seeing the growth the same every year. This little line bar here, red bars here, they should be the same every year. So that little thing is the growth change, change of y. How do I know this is y? Because this is x in the coordinate plane. This is y. So as you can see, this is the y change. That's why we call that delta y means the change of the y coordinates. For example, this is, let's just say 10 feet, and now this is 12. So the change will be 12 minus 10. Let's talk about the x coordinate change. Change of x means this. So from 0 year, that's 1 year, 2 years, 3 years, 4 years, 2, 3, 4. So from previously, we just showed you the picture. Now we implement, apply the XY coordinate plane. So this is X. This is y. So if you just look at the tree about 2 minutes ago, just look at the pictures. You don't see how this all these trees, the pictures relate to XY coordinate. Now you can easily see. So every 1 year increase. So what is the X change? Which means from year 3 to year 4, the difference, the change is 1 year. So you have 1 year, which means bring what we just said. Delta X means the change of X coordinates. In this case is 1 year, 1 year, 1 year. Now let's take a look at this Y change from 10 to 12 feet, 10 feet to 12 feet. So change of Y is 2 feet. Now that's the slope, which means 2 feet per 1 year. That explains the growing speed of the tree in some certain area. All right, next one, I'm going to give you another example about an airplane taking off. Take a look. So if you really, again, lay all these pictures, you can see a straight line. Now, if you say, okay, this is not really real, okay, this is just a picture. I'm going to show you a video from YouTube. There you go. Okay, so now you can see, you can really draw a line. Okay, I'm going to put you here. You can really draw a line here. Okay, I need to get a, okay. You can really see here is a line. Okay, now let me just, okay, give me one moment. I'll just copy this picture and then show you on here. It's away. Whoops, too small. All right, now take a look. Now you can really see the line. Draw. You can really see the line here, right? Again, you can find the distance, the height change from this point. The next one, you will see the nose of the airplane could be here. So you will find the height change. That is the change of y. Over how many seconds? Let's just say 2 seconds. After 2 seconds, every 2 seconds, let's just say 2 seconds, and that is the x, right? Remember, x is the horizontal axis. Um, so that's the change of x. So every 2 seconds, 2 seconds, you see the airplane has lifted, let's just say 4 feet. If you are interested, you can search online to find out what is the slope when they take off. And by the way, the slope is also the angle of this lap. So 4 feet every 2 seconds. Now go to the slope, then you will see change of y. In this case, is the height of the airplane, which is +2 because it's taken off. Over how many seconds? That is the x coordinate change. So that will be x. You can see that's every 2 seconds. Every 2 seconds, 4 feet up. Every 2 seconds, 4 feet up. So my bad, should be 4. Change it. So Now you can see the slope is 2 over 1 after you reduce it. 2 feet per second. I hope that after this example you can easily see what actually slope is in your life. You just never thought that, oh, this is slope. Okay, for example, when airplane taking off, it is a slope, right? Okay. Now let's go back to the PowerPoint. Now, the last one I'm going to show you is the car, which some of you are driving every day, right? So let's take a look. So, okay, now you press it. Wow, Mr. Lee, I don't see a line here, right? No, you don't. But let's apply it what we learned to XY coordinate plane. So this is time. X coordinate is the time in seconds. And this one here is the distance from the starting point. All right, so take a look. Time in minutes. Oh, in minutes. Okay. So notice that every 2 seconds is 3 feet from the starting point. Every 4 minutes, I'm sorry, 4 minutes is 6 feet. I know it's slow, but let's say you're walking. All right. Possibly I should change it to seconds. But the point here is that you can see that every 2 seconds, I would just say seconds, change it to second quickly. Okay. And every 2 seconds is 3 feet more away from the starting point. Every 2 seconds, another 3 feet away from another 3 feet more from the distance from the or starting point. Okay. So if you connect all these points here, right? There's a point here. That means if you write it down in coordinate plan, coordinate order pair, you will have 2 and 3, right? So you see how you can combine your walking situation or your driving situation into a XY coordinate plane. And this point you can see at 4th second, you are 6 feet away from the distance. And at 6th second, you are 9 feet away from the point, starting point. And 8 seconds, you are 12 feet from the starting point. So if you connect all these points, you see a straight line, which is like our previous two examples. So I hope you are pretty much convinced that slope is actually in your life. You just have to do some, study and thinking and apply the XY coordinate plan into the situation. So how are you going to find the slope here? Again, let's put some meaning into the definition slope. So we notice that the change of y here is 3 every time, right? 3 every time, 3 every time. And the change of y, um, here we go. I want to use some different color. Change of x is 2 seconds every time. 2 seconds every time. You count it 2 seconds every time. The car or you walk 3 feet more. Every 2 seconds, you walk 3 feet more. Okay. So back to the definition. Slope is defined change of y over change of x. Okay. So obviously change of y is, okay. Change of y is 3. In this case, I use red, 3, 3, 3 every time. In change of x, which is time, which is 2. Because from 0 to 2, increase by 2. From 2 seconds to 4 seconds, increase by 2, etc. So your slope for this situation will be 3 over 2. The meaning of that will be 3 feet over 2 seconds. Now let's reduce it. That will be 1.5 over 1. So now you can see the slope for this walking situation would be every 1 second you walk 1.5 feet. Okay, so I've introduced how we can see slope in the real life. Now, your assignment is, let me close it and go to the assignments place. Okay, so please do this. Your assignment is number 1, explain the concept of slope to your parents or guardian. The reason I want you to do this is since now you are not at school, you're at home, and I don't know if you have a lot of things to do. And I assume maybe your parents are at home too. So bring this to your parents so that you can have a, you know, family time learning together. Then your parents will probably understand why sometimes you don't get math. So they probably can be more understanding. And for you, you will also understand why some teachers are so frustrated just because you explain the concept to your parents and they still don't understand. And then you probably say, wow, my teacher is really patient. Anyway, just a good chance. It's not just about math. It's since we try to make the best of this school closure period of time. So bring this to your parents. Of course, you have to study previous the slideshows I explained. And when you are ready, explain this to your parents. Number 2, give some other real life example that can be used to show slope. Number 3, make a video. Like pretend you are a YouTuber. Okay, maybe you'll be famous if you really post it on YouTube. But I suggest if you really want to post it on YouTube, then try not to show your face or your parents' face unless you get their permission. You don't have to show your face on the video that you're going to send me. Um, as long as you demonstrate you understand it, your parents understand it, give some examples, then you're done with this assignment. So make a video and send it to me. And send it to me to tlee at fpschools.org. Okay, so that's it for the video. So hope you enjoyed it. If you have any questions, send an email to me at tlee at um, fpschools.org. I'll get back to you as soon as possible. Until next time, we'll see you. Have a good day. Stay safe, stay healthy.